Hi everyone, welcome to the Boost Chemistry YouTube classes. We have started our classes based on CSIR Chemical Sciences question papers, and we have started with organic chemistry basic concepts like aromaticity, conformation, and stereochemistry. Now, the next session of classes based on these topics. Some of the questions again asked in previous question papers are discussed in this video. Please do watch and subscribe this video so that it will help you to score big. Now, the first question that we are going to discuss here is the configuration at the two stereo centers in the compound given below. Here you are given a compound here, and you need to assign R and S configuration to the labeled 1 and 4 carbon atoms, which is quite an easy thing to do because in 1 it is based only on atomic number priority. You just need to align the 4 groups 1 2 3 4 in the decreasing order of priority. You need to look whether it is clockwise or anti-clockwise rotation, 1 2 3 movement. Whether if it is clockwise, then it will be R if the lowest priority group is below the plane, and if it is anti-clockwise, then it will be S. Okay, so based on this we can answer this question. Here this is the chiral carbon 1 which is marked here. So from here the first priority will goes to this carbon because this carbon has got an oxygen. None of the other carbon atoms have got oxygen in their ranks. So we can say the first priority group will be here. Then the second priority will be C double bond C, which is treated as C connected to 2 carbon. So second will be here, and the third will be the main the branch happening here. So it will be 1 2 3, that is clockwise rotation, and the lowest priority group is below the plane, so it will be R. So 1R will be the answer. Now coming to the fourth one, similarly we will have 2 carbon atoms here, here also carbon atom, but here this carbon is attached to 2 carbons, but here only 1 carbon, here only 1 carbon. So this is your highest priority group. Now coming here, we have this carbon here. This carbon is attached to this carbon which has an oxygen, but here when you compare this carbon is attached to this carbon where it is attached to only 1 carbon, right? So oxygen is has more atomic number than carbon, so we can say this is the first priority, this is the second priority, and this is the third priority. So 1 2 3, something like that is going to happen. So 1 2 3 is happening here. So 1 2 3 means it is which rotation anti-clockwise, but the lowest priority group is above the plane, so you need to reverse it since anti-clockwise, so it will be also R since the lowest priority group is above the plane. So the right answer is option A, 1R 4R. Now look at the next question. You need to identify the relation between these two compounds here. Given these two compounds, we can easily say they are identical because this structure is formed by 180-degree rotation of this one. So 180-degree rotation gives you the same compound, identical compound. So we can say 54B is your right answer. Now coming to the next question, look at this. The correct order of acidity of the following compounds A to C is. See, this question is based on aromaticity of the resultant anion. Aromaticity of the resultant anion after the removal of H plus. So if you remove H plus from here, you will get an anion which is aromatic, right? But here if you remove the H plus from B, you will get positive part, or if you remove the H plus, you will get a negative part here which is anti-aromatic because it has 4 electrons, 2 from here, 2 from here, so it is anti-aromatic. Here it is aromatic. What about here? It is also an aromatic species. It will give you an aromatic species right here. So these two will give you aromatic, and B is your least acidic compound, that you can say for sure. B is your least acidic because both A and C will give you aromatic transition states. So you can say B is the least acidic. So which is the option connecting that B is the least acidic? This is this one. A is most acidic, then C, then B. Because why? What happens in the case of A and C? In the case of A and C, what is happening here is that in A, the negative charge is stabilized by the electron withdrawing nature of the CF3 groups. But here the negative charge is getting intensified by the plus I effect of the methyl group. So we can say that this here destabilization will be there through plus I, but here it will be minus I as well as minus M effect is happening here, which will increase the acidity. So the right answer will be option C. Now, next question. The IUP is the name of the given compound. Here you are given a compound which has a carbonyl group, a ketonyl group here, a double bond is there, an ester group is there. And you first of all look at the options given here. First of all, you need to assign whether it is R or S. First you look at this carbon, this is your chiral carbon. Here need to assign R or S. R or S means this carbon has here it is attached to carbon, here it is attached to carbon, here it is attached to carbon. But this carbon is attached to 3 oxygens, I should say, since it is double bond. But here this carbon is attached to only 3 carbons. Here 3 oxygen, here 3 carbon. So this is your COE, it is your first priority group. This double bond is your second priority group, and this one is your third priority. So it will be anti-clockwise rotation and it will be S. So we can easily neglect option A and C, where it is given as R. Now look at the option B and D. What is the difference between these two? Both are S. But here we know that ketone, and between ketone and ester, ester has got the higher priority. So ketone will be considered as branch. Now in the case, in that case, what is happening here is that if you have found it's the S configuration, the first option, in the first option we have the ester in the main chain because it ends with carboxylate. But here option D, you have enone, that means ketone is considered as the given precedence, which is not right. So option D is not right, then option B is going to be your right answer. Look at the next question. Consider the following reactions. Among A to C, the correct statements are. Here it is given as lithium aluminum hydride. We all know carbonyl compound will be reduced to its alcohol. That is given here. And now look at this. What is the first statement? The carbonyl group has enantiotopic phases. This is the carbonyl group. It has got enantiotopic phases, which means it will be rephase or C-phase, something like that. But look at the carbon which is next to this carbonyl group. This is chiral carbon. If the carbonyl group is attached to a chiral carbon, it will be always having diastereotopic phases, not enantiotopic phases. So we can easily say A is wrong. Now look at the options, which in option A there is given A, in option B it is given A, option D it is given A. So only upon looking the first point we can say which is the right answer. Option C is the right answer, because the hydride attack is refacial here, because hydride will attack this carbonyl group from the plane or below the plane of the carbonyl group. This carbonyl group is on C phase, because this is your when you how you can consider it's a C phase, because this carbon has oxygen as the first priority, then comes this double bond, then comes this. So this anti-clockwise rotation, that is C phase is happening here. So H minus will attack the carbonyl through rephase, that is right, and it is a diastereoselective reduction as well. So B and C are right, so option C is your right answer. Now, look at the next question. The correct order of acidity of the compounds A to C, again based on acidity. Here this is your acidic carbon here between 2 carbonyl groups, and this if a negative charge is formed here, it will be stabilized by these carbonyl groups, right? It will be distributed. But if the same thing is happening here, negative charge, it can be distributed to this carbonyl, but you have a phenyl group here which can also donate the electron density to this carbonyl group, which can conjugate with this carbonyl group. So here the intensification of negative charge on this carbon will be higher, so stabilization will be less. So we can say out of A and B, A is more acidic. Now coming to option C. Option C, when you look at the C, it is the most acidic compound, because this O minus, OH become O minus, this OH become O minus, it can be conjugated to both this double bond and this carbonyl group as well. So both type of conjugation is here. Here it is only carbonyl, but here it has got double bond conjugation with the double bond as well as carbonyl group. So you can say in that case But you can say C is the most acidic compound, then comes A, then comes B. So option C is the right answer. Now look at next question. The mechanism involved in the following conversion is. Look at the what is happening here. Here you are given a compound, something like that, and there is given a base as well. Piperidine is a weak base. So what is happening here in the reaction is that this bond is getting, what is your product, PH, CH, COET, NH2. So this bond is getting cleaved here, right? And here you have got a double bond present here. So this is also going to leave here. And now in the case of piperidine, it is a weak base. You have a carboxyl group here, electron withdrawing group. So it can attack this or piperidine can abstract the proton from here, and it will give you a double bond here. Here the proton can be abstracted and it will give you a double bond here, which is E1CB mechanism. See, there is a clue for that. If you are given an elimination reaction which has an electron withdrawing group like carbonyl, nitro, cyano group, the elimination will be always E1CB, because in the case of E2 and E1 you need to have a good leaving group. Here it is not a good leaving group here. So A and B cannot be your answer. Serial elimination for that it should be pyrolysis. Since there is no heat conditions is given here, so sin elimination can be neglected and E1CB is your right answer. Again, it's the absolute configuration of the two chiral carbons which you can solve for sure. It's minus camphor. Here the first carbon. Here it is your first carbon. Now it is attached to this carbon. Here also carbon. Here also carbon. But this carbon is attached to what? 1, 2, 3 carbons, right? And this carbon is attached to 2 oxygen and a carbon. So this will be your higher priority group, and this will be your second, and this will be your third. So 1, 2, 3 anti-clockwise it will be, anti-clockwise it will be, so it will be S. So it will be S configuration. Since this is above the plane, this will be below the plane, so S will be the case. Now coming to the 4, here you have similar here, but here it is different. So this is your first priority group, then this comes your second priority because there is difference between these two carbon atoms. So this is your first, this is your second, this is your third. So it will be something like this, right? Something like this, a clockwise rotation. It should be considered as R, but here it is given in wedge here. So it will be S. So option D is your right answer. Now look at the next question. In the compound given below, the relation between HA and HB and between Br1 and Br2. Here look at this compound. Here Br1 and Br2, if you are considering a plane passing through this HA and HB, this will be reflected. So that means Br1 and Br2 are anisotropy. So which is the option? Br1 and Br2 anisotropy, and HA and HB will be diastereotopic as well. So option B is your right answer, which can be also proved by substitution of this HA and HB and find out the configuration. You will see the change here. But this is the most easy method. Just consider a plane of symmetry passing through this, and you will get the option B as the right answer. Now, this is a simple question. Given the energy of each Gaussian butane interaction is 0.9 delta G for the reaction. So here you need to know how many Gaussian interactions are present in the starting material and how many Gaussian interactions are present in this one. That you can know. And here the answer will be 1.8 kilocalories, because here three Gaussian interactions are here. Here only one Gaussian interaction. So 3 minus 1, 2. 2 into 0.9, 1.8 kilocalories is your right answer. Now again, IUPAC name of the compound. Here it is given as, it is which configuration? This is E configuration. So it will be E. So this is option C or D is your right answer. Now coming to this one. This OH has got the higher presence, then comes this carbon, then comes this carbon. So that means it will be clockwise R, but lowest priority group is above, so it will be S. So 2S3E, so option D is the right answer. Now look at the next question. Among the following esters, the one which undergoes acid hydrolysis faster. See, ester, this is all OCOCH3. This will be converted to OH, and this will be facilitated by the neighboring group. Here there is no neighboring group. Here there is a neighboring OH group which can facilitate the hydrolysis here. But since here OH is very far, here also there is no OH group which can contribute to the ester hydrolysis. So OH group can contribute to ester hydrolysis through hydrogen bonding. Okay, so here option B is your right answer, neighboring group participation. Now 58, question number 58. Among the following dibromocyclohexane, the one that reacts faster with the sodium iodide to give cyclohexene. So here the two bromine atoms should release to give a double bond here. and which will be possible only if the two bromine atoms are anti-periplanar, which is happening in option C only. Here it is anti-periplanar, so option C is your right answer. Now question number 63, this question, the hydrogens marked A and B are. Look at the relationship between HA and HB. If you replace HA with another isotope deuterium, you will get the nitrogen will be first priority group, and then COH, then deuterium, right? So this will be like this, anti-clockwise. Yes, but if you replace HB by D, what is going to happen? Nitrogen as the first priority, COH as the second priority, then comes D. Then this will be clockwise rotation, so it will be diastereotopic. Configuration is changed, so it is will be diastereotopic. Now, this question, among the following compounds, the one which has highest dipole moment is the molecule having highest dipole moment. For that, you need to assign aromaticity. You just need to consider this double bond and break it with the plus and minus. So if you have plus here, it will be anti-aromatic, so it does not have any highest dipole moment. If you consider here if you are having a negative charge here, this part will be aromatic, 6 pi electrons. If it is this carbon is having positive though, then it will be also aromatic. So both species will be aromatic if you split the double bond into plus and minus. So this is option B is your right answer. Now next question, the most suitable reagent for carrying out the resolution of racemic 3-methyl cyclohexanone. First of all, the only thing that you need to know is that for the resolution you need an optically active compound. Here, which is an optically active compound, and for also ketone should be resolved by using an ester. Here, this is not an ester, this is not an ester, this is the ester. So option C is your right answer. Now, next question, the most stable conformation of 1,2-difluoroethane and Dl2,3 butanediol. Butanediol, so OH groups, it should be gauche for the formation of hydrogen bond, which is happening here, on not in this one, so option is not right. It is happening here in option B and option D also, and in option Z as well. But now look at the next one, 1,2-difluoroethane. Gauche effect is happening here because two fluorine atoms should be close to each other. So which is the option connecting? This one, the two fluorine atoms should be close, two OH must be also close, which is happening in this option D. So these are the questions that I am going to like to discuss with you. So that's all now. Please subscribe to this channel. Some additional videos about organic chemistry and other topics will be given in due time. So please subscribe and suggest to your friends. Thank you. Please subscribe. Thank you all.